geography and geology of Canada are both very distinct and fascinating to study. From the eastern Canadian Shield to the interior plains and the magnificent Rocky Mountains, Canada is an amazing country with a magnificent landscape. In this program, we will explore the phenomena that created the Shield of the Northeast, the prairies of the interior, and the mountains of the west coast. We will also discuss the three types of rock found in these regions: metamorphic, sedimentary, and igneous, and the way the physical properties of each region have influenced them.
The Canadian Shield is by far the oldest geologic region in Canada. It used to be a volcanic mountain range from the pre-Cambrian era, 500 million to 4.5 billion years old, but was eroded away and is now a large expanse of exposed rocks and lakes. It covers 8 million square kilometers over Quebec, most of Ontario and Nunavut, a bridge along northern Manitoba and Saskatchewan, and part of the Northwest Territories. It is essentially a chunk of relatively flat, metamorphic rock, which has made its way to Earth's surface, which has been very stable for millions of years.
What exactly are metamorphic rocks? Think about an assortment of chocolate chips, white chocolate and dark chocolate. These represent different types of rocks. Perhaps they are metal ores, igneous or sedimentary rocks, which we will examine later, or other older metamorphic rocks. Many millions of years ago, when these rocks were deep beneath the surface of the Earth, they were subjected to great temperature and/or pressure and shifted around by tectonic forces. We can show this by putting our chocolate chips in the oven and getting them warm, but not fully melting them. So here we have our hot rocks. As you can see, they've started to blend together already. And we're just going to mix the soft rock material around a bit, as like they would have been moved around within the Earth's crust. Alright. Now, we can just wait for them to cool. And now, we have metamorphic rock. Of course, real metamorphic rock is not formed so easily, nor is it quite as delicious. Temperatures greater than 200 degrees Celsius, or 400 degrees Fahrenheit, and pressures of 150,000 kilopascals are required. Today, metamorphic rock makes up much of the Earth's crust. Metamorphic rocks are also often considered to be some of the most beautiful, examples including quartzite and granite.
The Shield is unsuitable for agriculture. The lowlands have densely packed soil, or are very marshy. Everywhere else, the soil is coarse and dry, and, in the north, frozen all year round. The landscape also makes large-scale settlement difficult. The metamorphic process, however, exposed great stores of minerals, such as copper, gold, and nickel, and so mining prevails as a strong part of the economy of the area.
The interior plains region, sometimes known as the Western Canada Sedimentary Basin, covers the 1,400,000 square kilometers between the Canadian Shield and the Rocky Mountains. It includes southern Manitoba and Saskatchewan, all of Alberta, and extends northwards into the Northwest Territories and slightly west into British Columbia. As the volcanic mountain range atop the Canadian Shield eroded, the rocks and dirt were deposited off of what was at the time the eastern coast. As well, layers of organic matter were occasionally deposited by flooding in the then tropical areas. Over millions of years, the rock layers turned to sedimentary rock and the organic material into fossil fuels.
Sedimentary rocks are formed by layers of sediment, meaning sand, dirt, and rocks of all shapes and sizes, compacting over millions of years. Take this shred of chocolate. We build up our sediment in layers. As we do so, we are building pressure as the upper layers weigh down upon the lower ones. Think about it. It's like being at the bottom of a human dog pile. all the people above you squishing you like a pancake. Eventually, the pressure becomes so great that the layers begin to compress. I'll just help this chocolate along here. So, the sediment compresses to become, well, rock solid. It takes a lot of deposited layers for this to happen, however. In the case of the rock beneath our prairies, the solidified sediment is 6 kilometers deep. The rock is unfortunately not edible, though the layered effect created by the sediment can create some of the most fascinating rocks. Sandstone is probably the most identifiable example of sedimentary rock, and similar to what we have with our chocolate. Conglomerate rocks are also interesting. They are made mostly of gravel, so they would look more like cookie dough with way too many chocolate chips.
Sedimentary rock is rich in minerals and natural fertilizers. As such, the interior plains can support an extensive agricultural community, primarily growing wheat and cereal grains. Currently, though, the base of the economy in the prairies is the extraction of fossil fuels and evaporates. Remember all that organic material that got squished between the layers of rock? Well, over millions of years, they were compressed until they formed pockets of oil, natural gas, potash, etc., all of which are very valuable resources in today's global economy. Because of this, oil-boom towns, like Edmonton especially, have sprouted up in what seems like the middle of nowhere, and the prairies have become a great contributor to the Canadian economy.
In Canada is, without a doubt, the Western Mountains. This region, a cordillera, covers over 1.5 million square kilometers from the Rocky Mountains to the Pacific Ocean, and from the U.S. border up nearly to the Arctic Ocean. What is a cordillera, you ask? Well, after the plains were formed, the North American plate collided with other tectonic plates and stray islands. The collisions of plates caused the land to buckle in a series of mountain ranges, valleys, and plateaus, collectively known as the Pacific or Canadian Cordillera. Think of it like this tower. As it gets pushed against my other hand, it begins to crumple up, like the tectonic plates did as they were pushed against the plains. The stray islands, however, did not cause quite much of a stir. While the ocean plates collide with a continental plate, the denser oceanic plate will subtract into the Earth's mantle, but any islands sticking up will collide with the coast like this. Some of these have contributed to the Queen Charlotte and Gulf Islands. Further south in Washington, submersion of plates have created volcanoes, which have contributed igneous rock to the West Coast geography, in addition to the sedimentary and metamorphic rocks added by the plate collisions.
Of all 3 types of rocks, igneous rocks undergo the most drastic changes during their formation. Underneath the Earth's crust is the mantle, nearly 3,000 kilometers of molten or liquid rock. The oceanic and continental plates which make up the crust float on top of this, but when they collide and subduct, it leaves space for the molten rock to come up to the surface through the cracks in a volcanic eruption. However, the rock would have to remain a minimum of 500 degrees Celsius in order to stay in liquid form. So, when it is exposed, it cools and becomes igneous rock. Think of it like these chocolate chips. I have white chocolate and dark chocolate, but if I melt it in the oven for a little while, voila, we have igneous rock. Now, true igneous rock can be either one of 2 types, intrusive or extrusive. Intrusive rocks are formed when the molten rock makes its way to the Earth's crust, but is still buried and not exposed to the air. In this case, it doesn't cool as quickly and has time to crystallize. Extrusive rocks, or volcanic rocks, are formed when a volcano erupts. The lava cools very quickly, and so the rock does not form crystals but is very fine-grained. And sometimes air bubbles even get trapped in the rock, forming a very interesting effect. 3 of the most notable igneous rocks are granite, which is intrusive, obsidian, the shiny black rock, which is extrusive, and pumice, an example of extrusive rock with trapped air bubbles.
There are 7 different mountain ranges and 4 major areas of the lowlands in the Canadian Cordillera. And this can make travel east-west across the region, BC especially, quite difficult. The mountainous regions don't support agriculture, but are often rich in precious minerals like gold, which is mined especially in the interior of BC. Some of the valleys and plateaus, however, are very fertile, and agriculture in these places is extensive. The southern stretch of the interior plateau, the Okanagan Valley, for example, has a very warm climate and is known for its fresh fruit orchards and wines. The Fraser Valley, at the river's delta, is also very fertile and grows a wide variety of berries, grains, and root vegetables. Both mining and agriculture contribute greatly to the economy of the region. Also, the beauty of the mountains and coast of British Columbia also makes the area popular for tourism.
As you can see, the geography and geology of Canada are spectacular.
From the ancient Canadian Shield to the oil-rich plains to the magnificent Rockies, our country is a widely diverse place.
It's a bit of a shame that everything isn't really made of chocolate, but this is made up for by the breathtaking landscapes, from sea to shining sea.